Assalamu alaikum. Assalamu alaikum warahmatullahi wabarakatuh and very good day. So I'm going to talk about the solution to the homework number 3, which is the synthesis of linkage mechanism. So, yep, without further ado, let me share my screen. Okay, let's get to the question. So this is the question, and we have these points, and how do we do this thing? Let me open AutoCAD and see if we can solve this thing. So I guess this is in inches, but yeah, just going to this one on this one. That's this inches inches, but that doesn't really matter. Okay, let's draw this thing. So we have line from 2.6, and then 8.6, 8.6. Then I'm going to copy because it's basically the same thing. Copy this thing from there to the new position is 9.2, 9.2, and this one I need to rotate it 50 degrees. Rotate this thing from there 50 degrees, so negative 50, negative 50. So it'll be like that. Then I'm going to copy this to 12. So copy again. Copy this to 12.6, 12.6. That is to 12.6. So this other part needs to rotate so that it will become vertical. So rotate over here, make it vertical like that. So yeah. So let's make this thing certain color. Our properties. Let's change it to any color, maybe this color. Make it thicker. All right. Okay, so A to this A, and another one A is like that. Okay, so let's create the line from here to here, here to here. So I can use that, but in AutoCAD, I guess the better way to do it is to use this 3-point arc. You can click here. Next one is here. Next one is here. And then for B, we'll go from B1, B2, and B3. So here, here, and here. Click. This is the the one for B. Okay, so that is the situation. So I'm gonna create. So we are going to get pivot points. So pivot. So here, if I click on that one, here is the pivot, and for this one, here is the pivot. Okay. So for this one, actually the real way to do it, is to connect a straight line to here, and then from there to here. Then line perpendicular to this one, another line perpendicular to this one, but you need to put it in the proper position. Must be in the midpoint. Okay, midpoint of that line or that section. And then you want to lengthen them until they cross each other, intersect. So dynamic. Like that, and you trim the excess. All right. So notice that is the pivot or the pole, and if I use this method, that one, and that one, if I click on that, you see the position of the pole will be the same. Okay, so in a CAD, I think we can do that. Okay, but similarly, you can do the same thing for this part, and you should get that as the pole, the other pole. Pole are the location of the fixed pivot. Okay, fixed pivot. Okay, so enough chit chat. So let me delete that. So from and delete these two lines. So let's recreate this thing. There. Okay, so the mechanism. So I'm gonna create the mechanism, which is from here. So that's for A, the link for A to there. And then for B, create another leg from this pole to B1. Okay. All right. So and then we're going to create another line from there to here. Okay, so this line, and this line is the 4-bar mechanism that we want to focus on to see whether they can travel to all the 3 places. So I'm gonna change their colors. Maybe make them chocolate one, chocolatey. Make it thicker. Tika, and then what else? I guess that's about it. That's about it. Okay, and then I can create this one. Make that a red, and let's fix the sizes. The sizes. Okay, using parametric. This one, let's make that 0.25, 0.25, or maybe a bit bigger, 0.3. Okay, that, I guess that will be enough. So that is one couple of that. So I need 3 more of that. Copy this one in the middle. There. I can just put one there. I can put it anywhere for now. Just bring them out. Doesn't matter. Okay. And we want to back to parametric, fix this length, and just accept that value. We don't want to change anything. Accept that value as well as this one. So their sizes are not going to change. Then they will be connected by revolute join there, revolute join here, and this is fixed pivot. It will rotate about over there. So we do the same thing over here, and now we can move this thing, and everything should be moving as well. Okay, see how they move. They will also follow that line, that curve, and we can hide all. And for the moving pivot, yes, we can put that over there. This one over here. Then the fixed pivot on the ground, and another fixed pivot on this ground. Okay, so want to make sure that this thing will be able to go. This is third position, and this is second position, and finally this is the first position. Okay, all right. So that's the machine that we have just created. Okay, so if you want to check in terms of location, this will be a pivot for point B, 13.3, 5.2, and for point A, here will be your fixed pivot or pole, 7 and 11 negative 11.7748. Okay, let's see if we can get that answers using this value. And how about that value over there? Okay, that is 5.1433 and whatnot. So we need to use this thing. So okay, let's use for let's go with the point for B first, or point for okay A. Okay, A pun boleh. A pun boleh. So let's call this thing, turn it on, and we have A 12 and 6. 12 and 6. So I'm gonna go to equation, 3 unknowns. Okay, A1 is 1, B1 is 2 times this one, 2 and 6. So 2 times 2, it's going to be 4, and this is 2 times 6. 2 times 6. And over here in the D, so that will be 2 square plus 6 square. Okay, A2, the second row is 1, B is A2 is here, so A2 is 2 times 5.1433, 2 times 6.59, 963, and that will be 5.1433 square plus 6.5963 square. And this, that is this one. Then A3 is 1. Then 2 times 12. 2 times 6. D3 is 12 square plus 6 square. So that is X. Okay. X will be this top part. So we can write somewhere what X is. So X will be maybe all these things, copy, paste, and that is equals to 153.2862. maybe I put it over here. 153.286179. Okay, then what is G? So G is that copy so J is 7 and copy this thing. That is negative 11.7738. Okay, and let's check that. So we have 7 and negative 11.7748. So that is exactly the pole for A, pole for A. And so if you want to find what R is, so this whole thing R, okay, small lowercase. So R will be what? R will be square root. Okay, here I have to go back to complex. So R will be, use this thing. So 153.286179 2866179 plus this thing 7 square and then plus 11.7738 square. Close that, and that should be 18.46. So this line over here 18.4647. 18.4647. So this one 18.4637. Okay, maybe something is off a little bit, but who cares? That is acceptable, I would say. And yep, that's about it. But for this one, we can also check what is that situation over there. So that's 5.36. Okay, for B, so this is what, so I got 11.4637. Okay, 11.4637. That is good enough. Doesn't have to be exactly the same. Okay, and and now we do for point B. So this is for point B. For point B, again, you can plug in the numbers there. Yes, for point B, you have all the numbers shown there. And yeah, get back to equation 3. Oh man, that is 1. B1 is 2 times x1, so where's B1? 2 times 8 is 16, and 2 times 6. So D is 8 square plus 6 square. So this is the first set. A1 is 1, and 2 times B2 is this thing, 9 and 2. 2 times 9, and 2 times 2. So there'll be 9 square plus 2 square. And A3 is 1. A3 is this thing, so it should be 12 and 0. 12 and 0. So that is 2 times 12. That is 2 times 0, which is 0. And D is 12 square plus 0 square. So for that number, here I got 175 negative. It's a negative 175.2. 175.2, and for y is 13.3. 13.3, and that is 5.2. Positive 5.2. Okay, then we can go back to complex number or complex calculation. So here we have negative 175.2 plus 13.3 square and plus 5.2 also square, and we got 5.36, which is exactly the same as this thing. So 5.36. Okay. All right. So I guess the units will be in inches. So let me move it out of the way a little bit like that, so we can add something like linear stuff from 0, 0 to that. You can increase the annotate dimension sizes here. Text, make it 0.5, maybe 0.5 period. Maybe just take two decimal places. Okay, so yeah, that should do it. Modify. Modify. Into 5. Fine. Okay, that's more like it. Then continue with the linear part, 0, 0, over there on this part. So this is the location for pull for A, and then for B, so 0, 0 to over here. And then maybe I can just bring it to that position. And then 0, 0 also to that same position. But yeah, that will be the X. And then what? The radius. You can use this one as well. So that is RA, and this will be RP. Okay, so yeah, right all. And use a snipping tool. Snipping tool, where is that? Snipping tool. And paste it over to the solution. Yeah, so that will be the key for that. Okay, let's take a look at the second problem. So definitely you have to refer to the notes on this thing. So here the stroke is 50, and we have something that cut takes 2 seconds, return takes 1 second. So basically it's a 60-degree angle that we need to have. So if I go over on this side, so the stroke will be a vertical line. So this one, I think I need to have it in centimeter or in millimeter. line. So let's say I start from 0, 0, 0, 0, and that going up there 50. So this is solving it using this thing. So that is the stroke. Maybe change this to a different layer, general layer. Then let's work with the construction layer. So I'm just gonna put draw the triangles. So this triangle, just draw like that from the start, connecting the start and the end of the stroke. So that is 50 here. And we know this is going to be 60. Okay, 60. So I'm going to go to parameter and maintain this position, start and end. So this is not going to move, not going to change. Can't move it anyway. Not going to happen, inshallah. And another thing I can set is that this line and that part is going to be connected. This part and this part is going to be connected. Okay, and theta m is going to be 80 degrees. So that will be some angle that I can set. So this is going to be 80. And I know this I want to always be connected as well. And I know this angle is going to be 60. You have to do the calculation. Calculation here to here is going to be 60. Is that correct? Okay. How do I know it's going to be 60? Okay, this one we have to go all the way. Yeah, you have to calculate it. So forward, that's 2, this is 1. So meaning Q is going to be 1, 2 over 1. So this is beta. Copy this. The solution. So this is going to be like that. Copy. And this is 2. 2 minus 1 is 1. This is 3. So this will be 1 over 3. So 180 over 3 is 60 degrees. So, yep, copy that. 60. 60 degrees. Where are you, degrees? Okay, that's more like it. So that's why I got wrong. That's why I got 60 degrees here. Okay, so now I think this is a bit, it's going to be fixed. So if I use the graphical method, so I have to do a little bit of calculation here. Okay, so have to get the information here. This one maybe go to text. Assalamualaikum warahmatullahi wabarakatuh and very good day. Okay, so that's my programming recording from previous class. So sorry about that. So layer, and I want to get that dimension. This one over here, and that one over here, over there. Modify, or maybe it's too big, so maybe 1.5 will be enough. 1.5 primary unit. This is a period. Make that 4. So I guess that's the measure. Modify the comma, needs to be a period. Why didn't that change? Okay. So yeah, I guess close. Oh, okay. Okay, one more thing I want it to be let's make a 1. This is centered and horizontal. Still doesn't change. Click this update these two colors, and you got that. All right, so you want to do this calculation. So R1 can be measured. Yes, this calculation can be copied. Okay, then copy the other one. Copy. Okay, so R1 can be measured. All right. Anyway, so this one, okay, is this. Or maybe I can just put here equals 1. Okay, so yeah, let's do this thing. So this is basically copy. So AC1 plus AC2. So basically these two things. So this is 19.7465 plus 56.8579. Okay, whatever that is. Take out the calculator. Oh, we have that calculator somewhere here. Use a calculator and just try to get that values. 19.7465 plus 56.8579 and divide that by 2. We got 38.3022 and so this one AC2, I guess AC2 is the bigger one. So this one, copy. So this one equals Control V. So AC2 will be that 56.8579 minus 38.3022. So 56.8579 minus 38.3022. So this one should be 18.5557. Okay. So this will be, that will be our R1. So R1 measured there, that to be 19.4465. Okay. Mm. Okay, in that direction. That's the offset. All right, let's see if this is correct. Okay, so we have from home, we want to create a line. Okay. All right. And let's give it a different color. different size. And let's also create a cutting something, cutting block. That's the cutter. All right, and then this thing, let's create this thing to be different color, different size, like that. And I'm gonna create a blade, maybe a cutter. Base point, I'm gonna go with, say, this one, this point. Then object, this thing. So we have a thumbnail there. Then let's go with OK. So this one has become okay. So this is the block. Okay, and delete this. This is the block. All right, that is the block, and okay, let's see. So R3, this is R3. So go to parametric. Let's see if we get this thing right. Parametric, it's going to rotate about that position. This is the center of rotation. And this length for R2 shall be 18.5557, 18.5557. And this bad boy is going to be 38.30 to 22, 30, 22. And then we need to connect them both over there and there. And this part is going to connect to, say, that part. And I'm gonna say to this must be sliding on that stroke. So I'm gonna use this collinear, get that line to this one. So let's see if we can add all this here, add all. Let's see if we can rotate this thing. So we'll go at that position, then rotate further until get to this position and continue in that beauty, in that beauty. All right, so you guys have fun already. Okay, so that is your R1, this is R2 and whatnot. Okay, another way to do that, if you do not have access to calculation, and definitely you can use this thing. So I leave it for you to test this stuff, see whether you can get the same answer. I believe you should get the same answer. We can try. If I take this thing, copy that, put it in here, Yes, I calculation. So here, if you plug in all those numbers and how to call that? So many things here. I call this scientific calculator. Put it on this side. So here for R1, stroke is 50 times double one. So the numerator have a sine that is 80 degrees times okay, 80 degrees times sine, another sine. This is 80 degrees minus 60 degrees. So 80 minus 60, and all those is the numerator, divide by sine of 60 degrees. Close that. So 19.4465 exactly the same as R1 there. So 19.4465. So the second one is this, copy that. Equals, again call the calculator. So we have 50 times sine 80 minus sine this is 20 lah. If I can just put that, divide by 2, divide by sine 60. 18.5557. 18.5557. So are we still not convinced? So we can copy this thing. Okay. Same over here. Call the calculator. 50 times sine of 80. Now a plus sine of 20. Divide by 2, divide by sine 60. 38.30. 38.3022. So the same as compared to the solution by graphical method. Okay, I guess that's a good place to stop. Maybe I include also this thing from maybe also create that ring of fire, not ring of fire, 1.5 degrees. 1.5, so we need like 1, 2, and 3. So 3, so how do I home modify copy? So need 2 more. Okay, so I'm just gonna go to parametric, get to the background, this one to that joint, and this one to over here. Okay, so height. So this is the mechanism that we can create. Okay, so where is that solution? All right. Okay, so I will share this thing, the PDF of it, save as PDF, and definitely I will also share this, this video very soon, and hopefully you can have enough time for you to study it. I wish you all the best for the tests, and don't give up, and yeah, see you in the hall or in the classroom. Okay, bye bye. Assalamualaikum.